This video is on special right triangles, and it's going to help you save a little bit of time when you're trying to find out the side length of triangles. You can always use the Pythagorean theorem to find the side length of triangles, but there are three special cases we're going to look at today. The first one is a 45-45-90 triangle. First of all, right triangles have this square in the corner or a 90-degree angle marker in the corner. And if they're right triangles, then you can use the Pythagorean theorem. But for a 45-45-90 triangle, when both the angles here are 45, the length opposite the 45-degree angle is the same. So this side and this side is the same, and whatever measurement you get would be x. And the side opposite the 90-degree angle would be x times the square root of 2. You could do the square root of 2 on a calculator, but oftentimes you just would write it out as like 6 square root of 2 or 7 square root of 2. And if you're trying to find x, they might give you this side, the hypotenuse, and they might say 9 square root of 2, and then you could just say that x is 9. We'll do an example of this. Here's our first example. The next special right triangle is a 30-60-90. Now you don't have to memorize these. You will have these special right triangles on your formula sheet. This is the exact image that you have on your formula sheet. A 30-60-90 is again a right triangle, and often you'll see either the 30 or the 60 degree marked in there. So you can't guess and think that it's 30 maybe. It has to have at least one of those angles marked on there. Opposite the 30 degree side is x. Opposite the 60 degree side is x times the square root of 3, and opposite the hypotenuse, or the 90 degree side, is 2x. So if you can figure out what x is, you can find all the other sides, or vice versa. Both of these two special right triangles are based off of the angles. So if you know the interior angles, you can find the exterior side lengths. The third example is the one that is probably used the most often, and that's a 3-4-5 triangle. And a 3-4-5 triangle is based on the relationship of the side lengths. And in a 3-4-5 triangle, you can take any multiples of the 3, 4, and 5 and find the side lengths. And we're going to do some examples of those. So let's see this in action. Using the properties of special right triangles, let's find A, C, and Y of this triangle here. So when we look at it, we've got a 90-degree angle. We have 45 here. 90 plus 45 is 135, and we subtract that from 180. We see that Y is equal to 45. How many degrees are there in a triangle, in case you've forgotten? Add them all up, 120, 35, 25, you get 180. No matter what kind of triangle you have, all triangles have 180 degrees. So Y is 45. Next we have to figure out what X is. So X is next to, there's across from, that is, the 7 side. So X is 7. That makes it really easy. You might think that's too simple, but it's supposed to be simple. That's why they're special properties, and we want you to use them. That makes A 7. So just by looking and comparing, you see, okay, well, 7 is the same spot as X, and so X is 7, A is 7. What is C going to be? Okay, so C, the same spot as X times the square root of 2. So C is 7 times the square root of 2. Let's look at an example of a 30-60-90 triangle. Okay, we have our 90-degree angle, our 60-degree angle, makes this one, makes Y, a 30-degree angle. Now we're trying to figure out what, we need to know what X is, we need to know what B is, so let's look and see what we can find. Down here, it's got 5 square root of 3 and X square root of 3. So if X square root of 3 equals 5 square root of 3, they're at the same location, that means that X has to equal 5, or 5 equals X. So if X is 5, that's going to tell us that B is 5. So this is 5. C then is 2 times X. So C is going to be 2 times 5, or 10. Right, let's look at our last example of a 3-4-5. A 3-4-5 triangle, basically you're looking at it and you say, okay, I see the hypotenuse. In this case, we're looking for the C. It's going to be some multiple of 5. So I have to just figure out the 12 and the 16 are what multiples of 3 and 4. So what numbers go into those? The number that goes into both of those is 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. So what divided by 4 is 5? 20. So C is 20 in this case. Here's another example. I've got 36 and 60. 60, this is the 5 side. 36, this is the 3 side, and my 4 side. If I divide both of those by 12, I end up with 5 and 3. So what number divided by 12 is 4? It's 48. I find that these 3, 4, 5 triangles come up the most, and they're pretty easy to figure out. So hopefully this quick review of special right triangles will help you be successful in finding the side lengths of triangles without using Pythagorean theorem, but you can always back up your answers when you find them by checking them with Pythagorean theorem if you have any doubts. Good luck!